Well, thank you everyone for taking the time to join us, and to Dr. Jafari for hosting me. You know, I was talking to him earlier, and I said today's a lucky day for everyone. You get to have two Dr. Jafaris in the same room. So I'm privileged to be here. Now, this is part of our webinar series. We do this, of course, free for educational purposes across the globe. And the reason we are doing this is mainly for the locals within that country, because I think it's super important for the locals to develop a thorough understanding of their own resources. And that is going to be a theme that we're going to continue discussing in this webinar. So unfortunately, I have never been to Afghanistan. I'd love to go. So the pictures that you'll be seeing are pictures I have taken, but this is flying over Afghanistan, because originally my parents and myself were from Pakistan, and I do a lot of work up in the mountains, you know, mainly for mountaineering and things like that. So I'm super interested in the mountains. So this picture you're seeing was actually taken on a flight from Islamabad going to Paris, but you're flying over the Vakhan corridor right there. So that's the Amu Darya right there. So on the left, we have Tajikistan, and on the right, we have Afghanistan. And you can see big Hindu Kush mountains. Speaking of big Hindu Kush mountains, there's Noshak, which is on the border of Pakistan and Afghanistan. Again, from the same flight. And that's a 7,000 meter peak. So gorgeous, gorgeous peaks out there. But anyways, here's the plan today. The plan is I'm going to do a brief introduction to who I am, just so you know what my background is. And then we'll get into it. I'll talk about what exactly placer deposits are. And then I'll talk about some of the stuff that the USGS has done and how you can actually use the information, because they've done a lot of high quality work. And it's a privilege to get this work done by the USGS, because unfortunately, when I do this webinar for other countries, they actually have to start from scratch. None of that has already been done, and they have to go in and do everything, you know, starting from step number one. Then I'm going to talk about how to successfully mine placer deposits. This is super important. And then of course we will have time for questions and answers. So what I would recommend is you wait on your questions and answers till the very end, and then they'll be able to address those. So this is my team here in Denver. And of course, not all of these guys sit in Denver. They're all working remotely. But we're a group of sedimentologists, structural geologists, and petrophysicists. And we all have our own specialty. But together, we provide consultation and training both for the oil and gas and the mining industry. So what I'm going to do real quick before we move on is let me see if I can change my mouse so we can make it a little bit more visible. All right, there you go. That's better. My own background is that I'm a sedimentologist. And for those of you who are not geologists, a sedimentologist is the person who is looking at sedimentary rocks. So if your mines happen to be in granite or metamorphic rock, that's not the sort of stuff that I deal with. When it comes to gold mining, which is what we're talking about specifically today, I'm dealing with gold that is in essentially modern sediments, or sediments that are not terribly old. So things that are at best maybe 1 to 2 million years old. As far as minerals go, I usually work with uranium, vanadium, copper, potash, coal, clinker, and then placer deposits. And these are some of the companies that I've either worked for these companies on a consulting gig, or maybe trained some of their personnel. So I do this work all across the world. This is where I live. Here's a map of Colorado, and I am between Denver and Boulder. Boulder is where I went to school. And if you look at a map of Colorado, the bright colors that you're seeing are zones where gold has been found. So Colorado is part of the Colorado mineral belt. And if you ever seen those cartoons, you know, when you were a kid with, what is it called? The guy with the hat and the big mustaches, you know, and he's always looking for gold. This entire gold rush that happened in the US that was focused on some of these Western states, which included Colorado, Arizona, and Nevada, and California. And so this belt, this mineral belt right here, you can see some of the numbers that are associated with that. Overall, the mineral belt has produced 25 million ounces of gold. So this was a fantastic place to go to school because we had plenty of field trips, going up to the mountains, looking at the sort of rocks that are producing gold. And here you can see one of these abandoned mines, which is maybe about a 45-minute drive from where I live. So I have the luxury of being able to go and look at these rocks and visiting some of these mines and seeing what worked for those guys. So that's my own background as far as gold goes. So whenever we present these webinars, I'm assuming we have a mixed crowd. We're going to have some students, we're going to have some professional geologists, we're going to have some investors and some mining engineers. So as I proceed through the talk, whichever category you belong to, I want you to be asking yourself some questions. So if you're a student, you should be asking yourself, how can I become better at resource exploitation in Afghanistan? Okay, because developing countries need to develop indigenous expertise, and students are a huge part of that. So you have to focus on, well, what kind of courses are available at the local university? And if they're not available at my university, where can I learn these topics? You'd be amazed. There's a lot of resources out there. And if you're curious about those, I'd be happy to point you in the right direction at the end of the talk. If you are a practicing geologist currently, then even though we're focusing on plasters, you know, this is a mantra I tell everyone, you're not focusing on the river itself, but focus on the rocks that the river has cut through, because that's much more important. So going along with that, if you are a practicing geologist, how good is your understanding of lode gold deposits? It's a fairly complicated process. I mean, the Canadians classify gold deposits into 16 different categories. So, you know, just because you're good at one type of gold deposit doesn't mean you're going to have a thorough understanding of the other types as well. So that is something, again, I would strongly urge you to do. Again, there are some resources out there. I'll be happy to go over some of those with you at the end of the talk. So again, the question you should be asking yourself is, where would I learn these skills? And then, of course, since you are a geologist, you have to keep in mind that if there are large international mining companies wanting to invest in Afghanistan, you'll probably be involved in the process. And if you are involved in the process, you have a responsibility not towards the mining company that you're dealing with, but to the people and the country of Afghanistan. So you have to ask yourself, what are the advantages / disadvantages of involving large mining companies versus consulting companies versus individuals? So these are some of the things we're going to discuss later on. If you are a mining engineer, then you should be aware that the machinery that we use in the exploitation of plasters is completely different than the sort of machinery that is used to exploit lode gold. Okay, so the question you should be asking is, well, what kind of machinery would be needed? Where would you be able to acquire that? And of course, what are the costs associated with that machinery? If you're an investor, then of course we are going to be talking about some specific areas, and you should be thinking along the lines of, okay, is acreage still available in these areas? If yes, what would be the cost of land? What would be my rate of return on an investment in something like that? Okay, this is something we're going to discuss almost at the very end. So that is the plan for the day. So the first thing I want to clarify is what the difference is between lode versus placer gold, because today's talk is specifically about plasters and not about lode gold. So what is lode gold? Well, here's just a schematic that I've drawn for you. Here's some igneous rocks, which are volcanic rocks. So whether the rocks come out of the volcano or whether they remain inside, we call those igneous rocks. And then rocks that form by pressure and temperature are metamorphic rocks. And especially if you're in a mountainous country like Afghanistan, and when the Indian plate collided with the Asian plate and it created a mountainous series, you guys get the Hindu Raj and the Hindu Kush ranges and the Pamirs. You've got multiple ranges within the country. So you do have metamorphic rocks there. Now, any sort of gold deposit that we find in place within metamorphic rocks or within igneous rocks, that would be an example of lode gold. Okay, so this is the gold that is still inside the rock. Now, what we're talking about are plasters. So how do plasters work? Well, here's an example. Here's some metamorphic rock right there. Let's assume it has a vein in it. And inside the quartz vein is some gold. Now, over time, what happens is it snows on the mountains, it rains on the mountains, and parts of those rocks are broken down. And they'll just sit on the hillside until rain washes them down slope, where they will collect, eventually washing into rivers, and then the rivers will start carrying that gold. So the rocks, the gold that we find in the sediments sitting on top of the metamorphic and igneous rocks, that is placer gold. And of course, I'm going to show you some examples. I'm going to get into some details. So again, a closer look at lode gold. So we're just focusing on something like this. Okay, so this is still in the rock. Here's an example. This is from Pakistan. This is from the Baltoro Glacier, which is a glacier that leads you to K2. So if you're hiking along, of course, you see these beautiful peaks, mainly made up of metamorphic and igneous rocks. And here, all those stripes that you're seeing, those are the veins that I'm talking about. Okay, I'm going to make a big deal about veins, and I'll tell you why. Here's a close-up of one of these veins. This one is not from Pakistan. This is actually from Colorado, very close to where I live. And you can see a close-up of one of these veins. Now, these veins can be filled with a lot of different material. The picture that I'm showing you, the vein is filled up with quartz. Well, how do you know it's filled up with quartz? Well, the color is milky white. And if you break it up with your hammer, it almost breaks up into pieces that look like pieces of ice. So clear to milky white. And the majority of lode gold in the world is associated with these quartz veins. So why is that important? Again, as you're looking at this, every slide that you look at, you should be asking yourself, well, why is he showing me this? Well, I'm showing you this because, again, when people talk about placer gold, I'm sure placer gold is not new to Afghanistan. People have been looking for placer gold literally for thousands of years. So you'll see people sitting right by a river and they've got a pan and they're moving it around, or they've got some sort of, home designed sluice box, which is just wood. And they're putting all kinds of river sand and gravels onto that thing. And they keep shaking it, looking for particles of gold. Well, originally, all of that, this is where it's coming from. So again, the focus should be on the rocks that the rivers are cutting across, because if you can learn to identify the right rocks, then you'll be able to identify the sort of rivers that would contain placer deposits. Okay. All right, so I showed you an example of what some of these veins in metamorphic and igneous rocks look like. Now we're going to talk about what residual plasters are. Okay, so again, here's a picture from Pakistan. These are the Deosai Mountains. So here's a mountain right there, and you can see on the hillside, you can see all the rocks that are pretty small, and they've broken up on the hillside, and they're just sitting there. So rocks that are sitting on the hillside, those are residual plasters. So let's assume that this rock here contained gold. Well, in this case, parts of it are getting broken down because of weathering, because of rainfall, heat, and then temperature fluctuations, and all of that is sitting on the hillside. Now, what people do is some people will actually collect gold from these residual plasters. So you would go up on the hillside, you would scoop a lot of this stuff into a bucket, but then the thing is, you need a rock crusher. You need to take all that rock, you put it into a rock crusher, and the rock crusher is going to grind it up into a powdered form. And then you take that powdered form, you put it into a gold pan, and then you will pan it, and then the gold will separate out. So that's something I want you to keep in mind, that if you are going to go look for residual plasters, then you do need rock crushers. And rock crushers come in all sizes. There are handmade rock crushers, which are about this big, so maybe about 1 or 2 feet tall, maybe about a foot wide, and you have to do all the hard work of crushing the rocks. And then, of course, there are, so that would be a manual rock crusher. There are also automatic rock crushers where you pour everything into a machine and it crushes it up for you. But eventually, you will have to pan it for the gold to separate out. Speaking of residual plasters, you can see that here, the rocks have this reddish color associated with them. The reason why those rocks are red is because they're oxidized. What does that mean? Well, what that means is, let's assume, you buy yourself a hammer, a screwdriver, and a whole bunch of screws, but then you leave them outside in the rain. Well, if you come back a month or so later, they are all rusted out. Well, why are they rusting? Well, it's because the oxygen in the air is reacting with the iron that's inside your tools, your metal tools, which is why they're rusting. Well, the same sort of process is happening here. A lot of times when these hot fluids that are carrying the gold are also carrying things called sulfides in them, things like galena and pyrite. And when those sulfides reach the surface and then years go by, they're cooled down, they react with oxygen, and with the reaction with oxygen, it converts them. And as a result, you get oxidized rock. So you get these red rocks. So when you see these red rocks on the hillside, that's a good sign. It's a good sign because it tells you that there has been hydrothermal activity in this area. Iron-rich minerals came up, they were oxidized by the air. So underneath this is potential, okay? So that was residual plasters. Again, these are rocks that are just sitting on the hillside. They have not been moved around much, okay? They've just been broken down by, just moved around by gravity, not really by water. When water starts acting on the rock, then we get what are called alluvial plasters. Okay, here's an example. So again, there's a picture from Pakistan, very close to the Chinese border. And here you can see the host rock, okay? And then right here, we have the residual plasters, which are again rocks from up here that are broken down and collected on the slope. But now when it rains, rainwater is going to collect some of these rocks and is going to move them, and you're going to get a deposit like this, okay? Now this has not been moved by rivers, it's just rainwater that has sorted some of this stuff. And sorting is very, very important. So I'm going to draw something for you real quick so you know why sorting is important. So when water is moving rocks, it's actually doing all the hard work for us. Okay, so it's helping us out big time. So when water moves rocks, what it does is that it deposits the largest particles first, then smaller ones on top, and then even smaller ones on top. So you see this pattern. And when you see this pattern, it's called normal grading, which means largest grains at the bottom, smallest ones towards the top. When you see that, you can tell that these rocks have been moved around by water. Now, why is that important? It's important because if there's gold in here, so I'm going to use red for gold. Gold has an extremely high density. So what the gold does is, even though it's very small, it lands up at the very, very bottom just because of its very high density. Okay, so whenever you're looking at these placer deposits, whether they're alluvial or fluvial, which we're going to talk about, the gold is always going to be at the very bottom, associated with very, very large rocks. Okay, so just because the gold particles are small does not mean that the gold particles are going to be hanging out with the rest of the small sized rock particles. They're going to be hanging out with the big guys at the very bottom. Okay, so whenever you see this pattern, largest grains at the bottom, smallest one towards the top, that is normal grading, tells you that water has moved the sediment, and that's what you would be seeing in these alluvial plasters. Okay, that's how you can differentiate alluvial plasters from these plasters that are sitting on the hillside, which are residual plasters. Now we're going to go Further downstream, we're going to look right around the river itself. So we're going to look at sediments, which are just pieces of rock like sand and gravel that have been moved around by the river. We're going to go take a look at those. So here's an example. Here's a stream. You can see these are the rocks that have been moved around by the river. And this is the ideal place to look, especially if you're looking at a bedrock stream. And what we're looking at here is a bedrock stream. So what is a bedrock stream? A bedrock stream is when the river is cutting across bedrock, which is the rock that the mountains are made up of right next to the river. Okay, so you can see that these rocks are what this mountain is made up of. And this river is not very deep. Now, if you look here, you can see that these gravels right along the margins of the river are sitting directly on top of that bedrock. Now, this is an ideal place. Why is this an ideal place? Well, it's an ideal place because, again, you have to make your life easier. If this were not a bedrock stream, okay, so let's assume this is a stream which is hundreds of kilometers away from the mountains, or even tens of kilometers away. And then you're like, okay, I'm going to go look for some gold. Well, you start digging. You have to dig all the way till you're at the contact with the bedrock. And that contact could be hundreds of feet deep. Okay, and so you don't want to dig that much. And besides, you don't have the tools to dig that much. Whereas here, you can see there's maybe 1 or 2 feet of gravel sitting directly on top of bedrock. So what I would do, if I were in this situation, is I would go here and I would collect the stuff which is sitting directly on top of the rocks, put it in a bucket, put it in a pan, and do a test pan in the water real quick, move it around, and then see if I can find something. So here's an overall picture, again, from northern Pakistan. I keep showing you these pictures because, you know, of course, I've never been to Afghanistan myself, but I've seen plenty of documentaries and videos. And of course, the terrain in northern Afghanistan is very similar to the terrain in northern Pakistan. So you get a lot of the same features. So again, here are the plasters that are sitting right on the hillside. These have not been sorted out by water. These are residual plasters. Here we've got alluvial plasters. These have been sorted out by water. The more sorting the water does, the easier life is for you because all the gold settles down to one interval, okay? And that's what we want. And then finally, here is a river. So the sediments sitting right next to the river, those would be fluvial plasters. So you've got 3 different categories in this particular area. Now, you should keep in mind that about 120,000 years ago, there were big glaciers in this part of the world, including northern Afghanistan. And glaciers are like bulldozers. They move a lot of sediment, but unfortunately, they don't sort the sediment like water does. So it's very important for you to be able to differentiate between deposits that were made by ancient rivers, where there is placer gold potential, versus glaciers that were not good at sorting, and there's really no placer gold potential there. But unfortunately, in places like northern Afghanistan, there are a lot of glacial deposits. And what do they look like? Well, they look like this. You can see this is a jumbled mess, okay? You've got rocks of all different sizes mixed in. There's no sorting whatsoever. So it looks like this. Big pieces, little pieces, big pieces of all kinds of shapes, and it's all mixed in. You stay away from this. This is going to be a waste of time. So don't go start filling up your buckets with this stuff and start panning, because that's not going to work, okay? What you're looking for is, again, is a situation like this where you can see all the rocks have been aligned in these layers, okay? And that is what you're going for. So it's very important for you to be able to distinguish river deposits versus glacial deposits in this area, because this right here is a waste of time, whereas this is what has potential. So the next thing I want to talk about is bedrock streams. How do you know that a stream is a bedrock stream? Well, again, very shallow, preferably sitting on the same rock that it's cutting into. So you can see here's some granite. This is a stream very close to where I live. You can see some granite right here. The stream is cutting through that granite. And you can see it's not very deep. So here's some gravels, but those gravels are sitting directly on top of granite. Again, makes your life super easy How so? Well, you show up here, you take that gravel, you put it in a bucket, you take stuff from the bucket, you put it in your pan, you start panning it, and then you can see potential. Again, in a location like this, you can do multiple test pans within about 10 minutes or so. Okay, so easy peasy. But you have to remember, not all streams are bedrock streams. So here's an example. Again, it's a picture from Pakistan. And you're looking at this stream and you're like, all right, you know, he said that the rocks, if there's red rocks, that's a good sign. And that's what you see over here. So you look at this and you're like, wow, this stream probably has good potential. But here's the deal. The deal is this valley, you can see that it's shaped like a big U. That was carved out by a glacier. And this is not a bedrock stream. So what does that mean? Well, what that means is, if we showed up here, let me draw this for you. So here's the valley. So here's the mountains on this side. Here's the mountains on the other side. And when the glaciers came across, they filled up this entire valley with glacial deposits. And then later on, the river started cutting into this stuff. Now, if you show up and you're like, okay, I'm going to go look for gold. Well, you have to go to the contact with the bedrock, which is down here. Okay, and now this vertical distance, yeah, this could be hundreds of feet. So if you're here and you're sitting right next to the river and you're like, okay, I need to drill down to the bedrock. Well, that's a lot of drilling. First of all, you're not going to dig down that deep. Secondly, unless you found commercial, or I shouldn't say commercial, but economic amounts of gold, you're not even going to try to drill that deep to figure out how much potential you have. So this is an example when you don't have a bedrock stream, which is what you're seeing in this picture. Okay, so again, for the sake of being able to test this stuff out, you need to look for bedrock streams and not streams that are cutting across ancient glacial valleys that have hundreds of feet of sediment sitting on top of the bedrock. Because where's the gold? The gold is not going to be sitting up here. The gold wants to go all the way down. So the gold is actually sitting right at the contact, right here. Okay, this is where the gold is at. Okay, so you can see it's a long ways down. All right, moving on. Here's another one. Is this a bedrock stream? No, it's not. It's not a bedrock stream. In fact, you can see the glacier back there. And of course, as a rule of thumb, all these glaciers were a lot bigger 120,000 years ago, which was the last ice age. Okay, so all these glaciers have been retreating, which means all the sediment that you're seeing here was actually placed there by the glacier, and now the glacier has receded, leaving all that sediment behind, and now that sediment is being worked by these rivers. So again, if you see something like this, just keep in mind that this stuff is, you probably have tens of feet before you hit bedrock down there. Now, if you're looking at this and you're a gold miner, or you've got experience in placer gold, and you're thinking, you're like, what is this guy talking about? Because I've been to streams like this, and I've found nuggets. So what is this guy talking about? Well, here's the deal. Nuggets are an anomaly. So yeah, if you're a prospector, which means, you know, you're a medical doctor, on the weekends you're bored, so you decide to go out there and you're looking for gold, and you've got a metal detector and you keep walking around and you find a nugget. Well, that's good for you. But when we're mining this stuff, we're not looking for nuggets, because nuggets, like I said, are an anomaly, which means nuggets can be almost anywhere. So let's assume some large boulder on this glacier had a vein popped open and a nugget fell out. Just because you find one nugget doesn't mean there's economic amounts of gold in that area. Okay, so nuggets can be fairly misleading. All right, so next thing we're going to talk about is visible gold versus disseminated gold. Because as I mentioned earlier, when there's about 16 different deposits of gold. And just because the deposit contains gold doesn't mean if a river is cutting through that area, you're going to be finding placer gold as well. Well, why is that? Well, here's an example. This is some orogenic gold associated with a mine in Australia. Here's a vein. And in that vein, you can clearly see the gold. So imagine this is a boulder sitting in the middle of a stream. As years go by, this thing gets broken, and parts of this gold are broken off, and now they're rolling around at the bottom of the stream. Okay, and they're heading to the very, very bottom just because of that high density. Well, in that case, if you show up and you're panning, yes, you're going to have some good luck and you're going to find some gold. But if you are looking at a Carlin type deposit, which is 65% of the gold that's produced in the US comes from this type of deposit, you know, the miners that have been working in these mines, they've spent their entire career working those mines and they've never actually seen gold. Well, why is that? Why are they mining it then? Well, the rock does contain gold, but it's what we call disseminated gold, which means it's microscopic. It's in the rock in very high concentration, but it's not big enough for you to be able to see it. Well, here's the deal. If you cannot see the gold in the host rock itself, well, you know what? You're not going to see it when it's sitting in the stream, and you're not going to see it in your pan. So if there are areas in Afghanistan where they are finding lots of gold, but it's all disseminated gold, well, then it's, again, those are not good areas for placer gold. So why are they mining this? Well, again, because it's microscopic, but the concentration of gold in this rock is so high that it's still economic to mine it. Now we're going to talk about the mining process itself a little bit. And when we're doing that, you have to remember that the mining practices for lode gold, which is the gold which is still inside the rock, is very different than the mining practices for the gold that is actually by the side of these rivers in placers. So this is an example of a mine in host/lode gold, host rock / lode, is the same thing. This is from Cripple Creek. It's again very close to where I live. And again, it's a pretty massive operation, and the machinery required for this, the technology required is completely different than what you use for placer deposits. So this is the machinery. What I want you to get out of this slide is the machinery that we need for placer deposits is completely different. Now we're going to talk specifically about Afghanistan. And when we are doing so, of course, we're talking specifically about gold. And when we're talking about gold, yeah, in theory, there's $25 billion worth of gold in Afghanistan, but you have to keep in mind that not all of this is in placers, okay? In fact, I would say the majority of this is lode gold. Now, the USGS has done a lot of good work out there. And what they've done is they've already identified areas that have potential for you. Okay, so there's two areas I'm going to talk about specifically. One of them is in Bedrock province, which is right here. So how do you use the work that has been done by the USGS? First of all, they've made it free. The reports are on their website. I've given you, at the end of this talk, there's a link that you can follow where you can download those PDF files for free. Once you've downloaded those PDF files, well, what's the next step for placer gold? Or for placer gold, again, what you would do is you would go into one of these areas that they've mapped out for you. Okay, so let me show you a Google Earth image. So this is in Bedrock province. That's the village of Ragh. What you would do is you're like, okay, according to the maps that these guys have created, there are gold-bearing veins in this area. So what you should be doing is you should be focusing on the streams that are in these valleys. Okay, that would be an excellent starting point. And again, you go there with a pan, and these pans are cheap. You know, you can get Chinese-made pans, dirt cheap, and you'll just use those. It takes about a minute for you to be able to find whether it has gold potential or not. So that's the best way to do it. Like I said, luckily, because of the work that the USGS has done, they've already pinpointed areas that have potential for you versus you going out and trying to figure this out on your own. The other one is the cutoff area, which is right here. And again, this is supposed to have potential. Here's another one. This is North Takhar, and very close to the Tajik border. And again, how do you do this? Well, you go there, and in this particular area, they actually have looked at the placer gold for you. In fact, the USGS has even assayed the gold for you. Assaying means you're sending the samples to the lab, and the lab determines the fineness of the gold, which is, what percentage of these colors are these small pieces of gold that you find, what percentage of that is actually gold versus other alloys or other minerals that are mixed in there. So they've done all that for you, and these areas do have placer gold potential. So again, doing this is dirt cheap. It's very, very cheap for you to be able to go out there and do an initial assessment of your own using one of these gold pans. And again, luckily all this stuff has been done for you. So it's like someone's already cooked the meal. All you have to do is show up to eat it. Now, once you do show up, these are the different steps in mining an area. Well, the first step is securing the area. Now, when I mean securing the area, as you know, I mean, this is Afghanistan, Pakistan, most of these countries, they have a tribal society. So of course you need to have permission to be able to do this stuff, and permission from the right folks, and have everything agreed upon in advance, because what's going to happen is you show up one day, you're doing a pan, and that's okay with them. The next day you call someone to do a proper survey, a geologist from a mining company, and he's doing the survey, and maybe they're okay with him doing it too. But the day machinery starts coming in, and they know you're actually finding gold, well, now their interest level in that has increased significantly. So again, all of that has to be agreed upon in advance so you can avoid problems in the future. So I know it sounds, it's common sense to do this, but you'd be amazed at how many gold operations in developing countries have gone to hell just because, by the time it actually got to the phase where you were recovering the gold, someone shows up and is like, well, yes, yes, you paid me X amount of dollars beforehand, but now I want an additional amount because, I want a piece of the action. Step number 2 is that the survey needs to be done by a competent person. Now, I cannot emphasize enough how important this is. 90% of gold placer mining ventures fail. 90%. So now think about it this way. If one of you guys was going to open a restaurant and you were going to make an investment, and I said, hey, you know what? There's a 90% chance that this business is not going to make it. You wouldn't be investing in it. All right. In fact, no businessman or no business person would be investing if they knew that the chances of failure were 90%. Well, I'll tell you this already. It's 90%. The failure rate is 90% for placer gold. Well, why is that? Why is it so high? It's not high because the gold isn't there. It's high because of inadequate sampling. Sampling is expensive because, first of all, you're not just using the geologist that works at your local geological survey or some college professor. So this email that I have for you, this is from an email that was sent by someone from Pakistan that had contacted a company here in the US. And if you read the email, when it comes to the sampling, they're like, oh, we've got a guy already, and since he's a geologist, he can conduct the sampling for your assessment. And what you can do is you can just email us on how to do the sampling and we'll do it for you. Well, man, you know what? If it were that easy, if it were simple enough for someone to teach you how to do it over an email, well, they wouldn't have to go to school for this stuff. People wouldn't need to get masters and PhDs in this stuff if it could be done over an email. or a phone call. I mean, it's a very, very systematic process through which gold is sampled. Okay. Once that survey is done, all those samples have to be sent to a lab, and those labs are charging per sample, and those lab charges can be expensive. And when I say we're sending samples to the lab, I'm not saying we're sending 10 samples to the lab or 20 samples to the lab. We're sending literally hundreds of samples to the lab. Now, oftentimes this is where I come in. So when I'm sitting with a client and I'm talking to them, I'm like, hey, you know what? This is how much it's going to cost. This is my daily rate for doing this. And then it's X amount of dollars per sample. The first thing they're like, hey, you know what? How about we cut the number of samples in half? Because they're trying to reduce their investment. And that is the reason why 90% of these mining ventures fail, because either it's inadequate sampling. They're like, oh, you don't need to send your guy. We'll do the sampling ourselves. And then the sampling is done in a way that just wasn't right. Or you were just skipping out on the assaying and trying to save money there. And then it comes and bites you later on. Step number 3 is, oftentimes I'll give these talks, and at the very end of the talk, someone is going to ask me questions like, hey, what is the economic cutoff for gold? How many grams per ton, or how many grams per cubic yard or cubic meter for this to be economic? Well, unfortunately, we can't do that. We can't do that for gold because the answer, it depends. So I've got 2 scenarios for you. Here's Kabul. Let's assume there's an area very close to Kabul right here, maybe a kilometer or 2 kilometers from the road. Well, here's the deal. When the operations start, we'll need machinery. We'll need to bring in backhoes. We'll need to bring in bulldozers. Well, how easy is it for me to get the machinery out there? How easy is it for me to be able to transport a trommel, bring it out there, and get things going? Well, if it's close to the road, well, that's not a problem. Machinery can come in and out super easy. Logistics are easy, and because logistics are easy, even if the concentration of gold isn't that high, this is still economic. Now, here's another example. Here's Rat in Badakhshan province. Let's assume this is the stream where you found the gold. And then you contact me or someone else who's in my position. And you're like, hey, can you come down and do a formal survey? How am I supposed to get up there? Okay, do we take a helicopter? Are we using horses? Are we supposed to hike in? So just getting there is a pain in the neck. So let's assume we do get there. Well, I could get there on horseback, or maybe I could just hike in. How about a bulldozer or a backhoe? How are we supposed to get the bulldozer or backhoe back there? So maybe we can still get it in there, but maybe we need to make a road first. So now the costs go up. So there is no magic economic cutoff number that can be provided. It's always done on a case-to-case basis. So this is, again, it's super important because the cost of producing gold is mainly the cost of moving material. Okay, what is the cost of moving per ton? Okay, what is the dollar amount per ton of being able to process this stuff? And again, the easier the logistics, the lower the dollar amount, and the higher the probability of that actually being economic. The last step is, of course, everything turns out, the geologist like, this thing is economic. Then you have to bring in the machinery. And here's an example of one of these larger trommels. And it's processing gold. And of course, when you're doing that, now you gotta have security on the site. You can see there's several bulldozers that are at it. And this machinery is not cheap. Bulldozers, of course, they're available. They're all over the place. You can rent those out. But a lot of this machinery has to be imported. So again, you have to start thinking about, well, where are we going to order this from? How much is it going to cost us? Do we have qualified personnel to be able to run this thing? So my recommendations, well, first of all, like I said, in your case, you are extremely fortunate in the sense that the USGS has done a lot of the background work for you. I've been through their reports. These are excellent reports. They're on the website. They're free. It doesn't get any better than that. You can go ahead, download these PDFs. They tell you exactly what areas are prospective. So you can go and focus on streams in those areas. Also, the one thing I always mention when I do these webinars is think about the pros and cons of involving large mining companies. When you think about the world's largest copper deposits, or the world's largest deposits of cassiterite, or some of these other expensive metals, they're not in the UK and they're not in the US. A lot of times they're in developing countries that are extremely, extremely poor. So we're like, how does that work out? How do companies that are so rich in mineral resources, how do they end up being the poorest countries in the world? And a lot of that, unfortunately, has to do with large mining companies. It's just the way they operate. They know that there's a lot of corruption in developing countries, and they thrive off of that. I'm sure you're aware of right next door to you in Pakistan, there's the Reko Diq mine, gigantic gold and copper deposits. The company that got into the agreement with local officials in Pakistan, it was a total mess. Now it's with the UN. There's some sort of lawsuit for $6 billion. If you try Googling the company, they don't even have a website anymore. Okay, so they've just they've disappeared. So bottom line is, when you're bringing these large mining companies, it's on you to make sure that when these resources are exploited, that it benefits the people of that country instead of a few individuals who are corrupt who become super rich. Okay, and sometimes people have good intentions, but these companies bring in contracts that are 30 pages long. So if you just get a regular lawyer that's used to handling local disputes, land disputes and marriage disputes and things like that, they're certainly not qualified to read contracts like that. So maybe it's actually worth hiring a specific contract lawyer who can read those contracts and make sure you guys aren't being gypped. I think it's super important to develop indigenous expertise, which means train local Afghans. And the best way to do that is, again, by bringing in the right people, the sort of people that will train the Afghans to do this themselves versus relying on a large mining company. Because again, these large mining companies, when they're coming in, they're not interested in training locals. They're in there, they get what they want, they're out of there. Okay, so again, I shouldn't generalize. Not all large mining companies are like that, but again, that seems to be the norm. So spend the extra funds it takes to sample and exploit a resource effectively. I cannot stress this enough. So you decrease that risk that's associated with placer mining as a business. So I hope this was useful. And at this point, if you have any questions, I'll take those from you.
Thank you, Dr. Jafari, for the nice presentation. And of course, you did it very well.